Okay, at this point, we have provided a very general overview of the Microsoft XNA framework. We've talked about the different assemblies that make up the framework. We've talked about some of the namespaces found within some of the assemblies, and we've shown you some of the more popular types that are defined inside some of the namespaces. All right, that's all good. But what we have not yet shown you is how all of these different types can be tied together to create an actual game framework for you to create your game. And that is the idea of this video. In this video, what we're going to do is take a very basic XNA game. And that's what we're looking at right now. And I'm talking about super basic. All I did was file, new project, Windows game. I haven't added any code whatsoever. But we're going to take this and we're going to look under the hood. We're going to use Reflector and show you how a lot of the things connect up. That's the idea of this video. I mean, think about it. When we create an XNA game, we start out with this template right here, and we start adding our own code in. We come down here, and we start adding stuff into initialize and load graphics content, and then we come down here with update and finally draw. We put all our code in there, and then we hit run, and a window pops up, and all of our stuff starts to happen. But where did this window come from? How did the game loop get started? Where does the game loop reside? We know that update and draw gets called 60 times a second, and we can even change that. But where does all that get set up at? How are we keeping track of time? I mean, I don't know about that. I mean, how does initialize get called? How does load graphics content get called? I mean, all of these different methods sit here, and they're waiting on you to come in and start adding your own code to do. Load any resource, blah, blah, blah. So write your own code here. But how do they get called? So here we are with a very basic game framework. We start adding our code and everything just magically happens. But what I'd like to do is show you that there is no magic at all. The framework makes it very easy to tie all of these pieces together. And there's actually a lot of stuff that you can expose that's up under the hood that will allow you to add additional functionality to your game that's just not there by default. Now, is this video a must? You can skip this video and it's not going to hurt you. But, my opinion, the more you know, the better you are. The better you understand this technology, the better you're going to be at writing XNA games. Not only that, having an understanding of how something as complex as this framework is all put together might help you in the future when creating your own framework for some large-scale application that you're putting together. Wouldn't you agree, Logan?
Right. Not to mention the fact that understanding things that are happening under the hood will actually help you advance your understanding of XNA in general more quickly.
Agreed.
You'll end up seeing a lot of things that you might not otherwise stumble across until you're looking at maybe someone else's code in the future.
Exactly. So that's what I'm saying. I am saying that you guys are welcome to skip this video, but I would suggest that you do watch it. Now, it might be a long video, and it definitely is going to be tedious. There's going to be a lot of writing because even though I'm going to provide a very generalized look under the hood, it's kind of like you're looking at a motor under the hood of a car and you say, you know, that's the manifold, that's the radiator, that's the carburetor, that's the block. Okay, don't close the hood. I mean, there's still a lot more going in when you start getting deep down all the way to the crankshaft level. We're not going to do that, but it's going to be a generalized overview strong enough that will help you if you feel like going into Reflector and tracking things down even further than what we're going to provide in this video. And not only that, if we were to truly trace every single object down and how every object connects to every other object and how every event gets triggered, etc., or not only triggered but subscribed, etc., this video would take a very long time, and I would write so much my left hand would simply fall off. So that's not a good thing. So again, a very generalized overview, but by the time you walk away from this video, you should be able to hit Reflector and trace things out yourself, and you should have a pretty clear picture coming together as to what happens the moment you hit play with your XNA game. Now, I just mentioned events a second ago. Let me go ahead and say this. For some of you out there that might be just a tad bit shaky with your programming skills. You know, you feel like you're just starting to get this stuff. It's all coming together. And in this video here, I'm going to show some pretty daunting stuff. It's a really massive framework that's all glued together in a very nice and neat way. It may look very scary. Don't worry. Watch the video anyways. I'm not going to treat these events as anything mystical. I'm just going to outright say this event handler is being subscribed to this event. And if you have no clue what I'm talking about, that's okay. I'll give you a very general overview the first time I talk about it, but then we'll move on. Later on, we're going to be covering events in the XNA class, and after you watch that section, then come back, rewatch this video if you feel like anything's a little bit confusing. But I have a good feeling, a very strong, sneaky suspicion that by the end of this video, you're going to have a pretty good idea of what's going on. So that's just a quick intro as to what the plan is. So with that, let's go ahead and get started. Now, I'm going to break things down into as small of components as I can, because if I just go blah and present you with the entire lesson, you will be very confused. And I know that firsthand because as I've been preparing this lesson, I have been testing different methods of presenting the material to people around 3D Buzz. And most of them would go blah, and they just wouldn't get what I was trying to explain until I broke it down into super simple stuff. And let me show you what I'm talking about. Let's go ahead and jump over here to the whiteboard. So super simple. What's my idea of super simple? Logan, please feel free to stop me at any point if I give any sort of information that doesn't feel super simple.
So far, I think you're doing all right.
Thank you very much, sir.
Got a couple of lines going on there.
Yeah, no, not bad, huh? So we start out with a box. You always start with a box in life. This is an XNA game. This will represent the next generation of XNA games that are going to be created from students out of this course. Now, a lot of different things go into the creation of an XNA game. Now, please keep in mind, we are not talking about an Xbox 360 game at all as we work our way through this video. We are simply referring to a Windows XNA game. The world of Xbox 360 stays very similar for the first half of this, and then its whole host environment changes because, of course, it's on a proprietary system, the Xbox 360. And we don't have access to all of the goodies code-wise that's going on in the Xbox 360. So we're going to focus on this in detail from a Windows point of view, which means, oops, hang on, let me undo that, which means we're going to have a window. So here we are. Give it a little title bar. Give it some buttons. So that is one of our components. Another component that, of course, is very important is going to be the game loop. So I'm just going to come up with a little icon here for the game loop. That work for you, Logan?
Yeah, looks good.
So we'll go ahead and label this as a game loop. So we have a game loop somewhere inside of an XNA game. What else do we have inside of an XNA game? Well, we have the game one, as we've seen, C# file, which contains initialize, load graphics content, unload graphics content, update, and draw. And, of course, the constructor. Where do all of these methods get magically called from? So let me see if I can, I'm going to do the best I can here at drawing something that's relatively straight. Let me move something out of my way real quick. So bear with me 1 second while I put this together. All right, we've got initialize. I'm not going to write all these. I'm going to write a few of them, and I'll check them off as we work our way through. So there's the initialize method that we can come in and write our own code inside. We've got load graphics content. Okay. And then let me just throw the two popular ones down. Update. And update takes in a game time. And I'm not going to write out the entire signature here, but let me just throw game time in there. Game time can be very useful to us when we're coding out our own logic and all, and we're doing stuff that requires some sort of changing value or the game time itself. But where does game time come from? It's like another magical piece of the puzzle. So let's go ahead and just throw that in there. And then draw. Put draw in as our last one. and withdraw once again, game time. Alright, so now if I can, as neatly as possible, we'll finish this box off. Alright, so all of these guys, of course, are residing over in Game 1, in the Game 1 class. Alright, so here's my question. Where does a Windows come from? Or a window. Where does the game loop come from? And finally, who calls all of these methods? We know they get called. We can put code in there and we see our code get executed. But who initialized the call or initiated the call? Oh, that sounds better. All right, so this is the great mystery that we want to unravel in this video. Now, we've seen the XNA framework, all the assemblies, all the namespaces, all the different types. Think of all of these different types as puzzle pieces scattered across your table. And the idea is for us to take all of these puzzle pieces and put them together in such a way that, hey, we have a picture. That's what we're going to do here. So, first, a window. I want to just kind of divert away from this lecture real quick and show you where a window normally comes from. Logan, let's go ahead and bring up the visual, there we go, bring up Visual Studio and create, if you don't mind, an actual Windows application. All right. So here we are with a regular Windows application, and without doing anything else whatsoever, we come up here and we run it, and lo and behold, we get a window. Window has minimize, maximize, close abilities, resize ability, has a title bar, caption, etc. Where did all of this come from? We didn't have to do anything. We just said create a window. Now, we all know in programming, nothing's magic. The bottom line is you have to tell a computer to do something in order for the computer to do something. Let's go ahead and take a look at some code. So I'm going to open up our program C# file because it contains our entry point into the application. So there's main. Now, when working with an application, our assemblies, when we launch a program that was written, a .NET program, we're always within the confines of an application. This is an application. When we run our XNA game, it is an application. Okay, so please keep that in mind. Here's what I want you to be aware of what happens. We address the application and we do a couple things that some of you probably have no clue what is. That's fine. Ooh, but this last line is extremely important to me. Look what we do here. We create, well, first of all, we're calling upon application to run its run method. So we're calling on the run method, and we're passing the run method a form. But not only are we passing it a form, we are instantiating the form and then passing that to it. Okay, so we're actually creating a form. So inside of here, we're calling upon the forms constructor. Okay, Logan, open up the form for me. If you can open up the code inside of form 1. Thank you, sir. Take a look at this. So here's form 1. It inherits from form. Very, very important to understand. Form is where it's all at when you're dealing with a window. Okay, so that's where everything comes from. So form 1 extends form, and then back over here in program, we call upon applications run, and we pass it that new instance of the form 1 class to it. And what does this guy do? What this guy is actually going to do for us, the run method, is he is going to basically start up our standard application message loop. Okay, so our message loop gets started, and it makes the form that we sent to it visible. So check this out. Just the instantiation of the form right here creates it in memory, but doesn't make that window visible. By calling upon application.run, not only does it start the application's message loop, it also makes the form visible. So that's what this run takes in. It takes in a form. All right, very good. So that means here we are back over in our XNA game. When we come up here and we hit run, what do we get? A window. Look at this. It's got a title bar, minimize, maximize. It's got the close abilities. Now, at the moment, we don't have the ability to resize and we don't have the ability to maximize because those things have been deactivated by default. But it is indeed a window. Okay? And since we know that we're still running a .NET application here, I mean, we are running an application. So at some point, a form had to be created. And that form had to be passed to application's run method in order to be shown and for its standard loop to be started so that I can drag the window around and have it respond to events, etc., like close it. Okay? Where does all that take place? So now that we've kind of babbled on about that for a second, like I said, I was just going to kind of divert just to show you that a window does come from somewhere, and now you've seen where it comes from. Now let's go and start focusing back on our game. So here we are, XNA game. What I want to do is continue to keep things real simple, because Logan's going to get on me if I don't. So I'm going to take this to the next level. So here we are once again, drawing out some lines. So this is once again our XNA game, but now let's look over inside of it. Inside of our game, we've got two things. We've got program. So the program C# file, and we've got, by default, our game 1. .C# file. All right. What does program do? Let's come back over here and let's take a look at program. So our entry point in the main. Talk about the easiest application in the world. All we're going to do is create this variable game of type game1, and we're going to hold a reference to an instance of game 1. All right, so let's break that down in layman's terms. We are going to instantiate game 1 and hold a reference to it. Woo! That means we're going to take this guy and turn it into an object. Simple enough. And then after we do that, we're going to then turn around and take a look at that new instance of game 1 and call upon its run method and let the whole show begin. Sounds pretty simple. Let's jump back over to the whiteboard and add some of that in. So here we are. Our program file has got some code in there that looks similar to this. So game 1, game. So a variable called game of type game 1 equals new instance of game 1. And go ahead and throw in so that we know we're calling game 1's constructor. Then we turn around and we say game dot run. That's the whole program. Simple. All we need to do is come in here and create an instance of game 1. So here's our object. And then call on its run method. Seems pretty simple, but that does not yet answer the question as to where does a window come from? Where does the game loop come from? How's initialize called, update, etc.? All this stuff. Where does that take place at? Well, let's start putting it together. So far, Logan, is this nice and clear?
It's all things that we've already seen in XNA games so far. So yeah, I'd say it's perfectly clear.
All right, very good. So when it all begins right here at the creation of the game object. Okay, so we instantiate game 1. Let us take a moment and come over here and look at that game 1 class. So here we are, public class game 1 extends the Microsoft.xna.framework game. So game 1 is an extension of game, which means we're going to inherit a whole bunch of stuff from game. It also means something else. That means before we can fire our constructor, we need to fire the game's constructor. We know all our constructor does is creates a new graphics device manager and a new content manager. But does that make a Windows? Maybe. No, it doesn't. What about the the content manager? I was about to mix all those words together. Cool. Does the content manager create a window? No, I've already talked about the content manager. He will load content into the game for you. So that constructor doesn't do it. Does this constructor? So this is where we can pull out reflector. So here inside of reflector, we can come over here to the Microsoft framework, into the game, And then inside here, let's just open up the assembly. And then open up framework. Here's game. Come down here to game. Just tap spacebar real quick. We can take a look inside of game. Let's go ahead and open it up real quick. Go to its constructor. Logan, looks to me like a few things take place. Wow. This is way before we even get to the run method. So what I want to do is just back up a little bit. I just want to keep everybody in a loop. I want to keep this picture as clear as possible. Let's come all the way down here to our game. So here we are with that Windows Game 1. Let's jump into the assembly. Come down into the Windows Game 1 namespace. And there's game. Once again, I'm just backing up what you've seen over in the code. Class Game 1 extends game. And look at the little context pop up. Microsoft.xna.framework game. Let's click on it. Tink. Here we are back up here this game. There's the constructor. So before we can call Game 1's constructor, we must call the base class's constructor. That's just how constructor stuff works. We've already gone over that in detail. So what happens inside here? Well, we can see that there are a bunch of different things that are happening. Setting up game time, calling some methods. We are subscribing some events. Bunch of interesting stuff. We're making some new objects. Yeah, buddy. What's important to us in here right now? Let's take a look. Let's go ahead and jump back over real quick to the whiteboard. And let's jot this down. First thing, game constructor. So I'm not saying game 1 constructor, but the actual game constructor. That's back in the framework. All right, several things are going to happen. We are going to create game time. Seen game time before? Yes, you have. On this page. Game time is going to be an object that's going to be used for holding timing information that we're going to use throughout our game. You've already seen it being passed to things like update and draw. Okay, let's take a look at that real quick. Once again, hopping back over here into Reflector, it happens pretty quick. We have a local field, a field for game that's called game time, and it holds an instance to game time. All right, very cool. We come down, we do a bunch of other stuff that at the moment is not very important. Game services get created here, but I don't want to get into game services in this video. A little bit too much. Ensure host gets called. Now, inside of ensure host, the whole idea is to ensure that we have a host for our game. This is very important. The host environment changes depending upon the platform in which you're going to run your game. The host environment is different in an Xbox 360 from what it is in a Windows game. So inside of ensure host, some very important stuff happens. Let's click on it real quick. You'll notice all we did was just jump down here. We're still inside of game. So inside ensure host, it's all about this host field. Okay? With the host field, which you can see if we come back up here to game, and you come on down, you'll find there's host of type game host. So inside ensure, we are going to create host. Host is holding a reference to a Windows game host, and we pass to the Windows game host ourself. What is ourself? It's a game. Where does all this stuff come from? It comes from game 1. So we have passed a reference to our game to the Windows game host. We are now on the mighty journey for creating a window. Not displaying one yet, but creating one. Because to follow this all the way through, when creating a Windows game host, well, it has a constructor. It's going to fire. And then it's going to create a Windows game window. And it's just going to go on until we have a window that's in memory, not yet being shown. We'll actually take a look at that in a few minutes. So what I want to say right now is that basically what we're going to do is we set up the host. Does that sound good, Logan?
Yeah, we need to, in setup, that basically more or less directly means creating the game host itself. We can refer to it as setup because it's
going to hook up a bunch of events and do all the setup stuff.
And not only that, it's set up in a way that one could call it repeatedly and not break anything. If you notice, it began with an if statement to make sure we don't create a duplicate host.
That's right. So here we are with a host. So we create it and set it up. Definitely getting created. And so this is what's responsible for, in the end, creating a window. So this guy, just for starters, he's tied to a game host, which gets extended into a Windows game host, which then creates and creates and creates until you finally have a window. So you have some layering between the window and us, the game. Now, I don't think I'm going to let you off that easy. We're going to come back to that. We're going to see what all gets created. But right now I want to keep things as simple as possible, or Logan's going to pick up this mallet over here and use it on my head, because we have to slowly introduce you to this. So we've created game time. We've created and set up the host. What else do we need to do? We need to, we'll hook up some events. So I'll just say register events. So register events. And I'll just put and create the game clock, just because I'm starting to worry about saving space on the page now. So create game clock. So let's go ahead and jump back over here real quick. So once again, back up in the constructor for game. So we've got our game type. We've called upon ensure host, which we know inside of ensure host, not only did we get our, what in the end is going to result in a window, but we've then done some subscribing. Ooh, what am I talking about here? This sounds like some fancy stuff. Nah, not really. Basically, what you can do, Windows is an event-driven model, bottom line. Okay, everything in Windows, all event-driven. When we create a window, there's a bunch of events going on in there. In fact, we're looking for those events. And you've seen events before. Let's think about it from very simple Windows application programming. You create, let's go back over here real quick. Logan, inside this, do a couple things for me. Drop a button on Form 1.
Okay. I need to bring up the toolbox for a minute, so I'll do that. And then I'll jump down to button and draw out a simple button.
I'll go ahead and close that toolbox off just so we keep it out of the way. All right, now what I want you to do, now we all know that this button has an event associated, don't we? If we were to come over here, events. Events, there's a lot of different events that can be picked up. Let's go ahead, Logan, and use the standard event.
Which should be mouse click. Which I could
you
use
just double click up there.
Double clicking on the button. But if we grab a mouse click event and double click in the events window, it will create an event and an event handler for us.
That's
so
right.
Really what it's done behind the scenes, we need to look at the forms designer and jump down to where the button gets created, and we should see the
right there.
Mouse click get subscribed.
Yep. So right here, basically, we have a mouse click and subscribing, or basically what we're doing is we're hooking up an event handler. What's the event handler that we're hooking up? Form1 underscore mouse click. Form1 underscore mouse click is a simple method where we're going to put our own code of what's going to take place when the event is triggered or raised. Okay? So that's all we're doing here. We are simply doing some subscribing, or what I like to call registering from time to time. We're registering this method. Hang on, let me see if I can highlight this so it makes a little bit of sense. We're registering this method with this event. When this event is raised, which that happens by you clicking on it, then this method automatically gets called. So that's the whole idea. Event gets raised, it calls all methods that have subscribed to it. There you go. There's a very quick lesson on events. We're going to come back to events in detail later in the XNA class because it's very powerful stuff, very useful. But in this particular case, you need a very general overview because as you see, look at this. We're doing a whole bunch of event registration right here. So we're basically saying that when a particular event is raised, such as when the host's idle event is raised, call this .hostIdle. So if this event gets raised, this method is going to automatically get called. HostIdle. HostIdle right here. And then when it gets called, it's just going to function like normal. And you can see it turns around and calls the tick method. What I just showed you is just the start of where the timing stuff gets hooked up. But these events are very important. So let's go back to inside here. We've got game time created. We ran ensure host, where ensure host played a very important role in getting our Windows game host established, which that continues a trickling all the way down to a final form that's created in Windows, or excuse me, in memory. And then we hook up a bunch of events, so we register all these events. And then we finish firing off the constructor, which does involve some more registration of events, including the host's window paint. That's a pretty important one. So all this stuff gets set up. Then we create the game clock. So there's our game clock getting created. And then we do a few things with time and all. So that's the constructor. So really a bunch of initialization has been taking place at this point. We've got a few objects established that are going to become very important, like game time and the game clock. And we've got a Windows created and a host environment for our Windows to reside in. The host that's going to kind of serve as the intermediate level between our window and the game itself. Okay? And we've got all these events hooked up. That's nice. Now, that's the game. After we're done with that, what do? We come back and fire our games constructor. Because remember, this all started back over here on the whiteboard when we called on new game 1 right here. So, of course, that was the worst line in the world. But when we called on new game 1, that caused the game constructor to fire first. And then we're going to come in here and call on game 1's constructor. Automatically.
So at that point, we're back into the world of what we can see from within a game when we've created it from the template. Now we're looking back into the world of game 1 itself. Exactly.
So what goes on in this constructor? Well, we know. We've already seen it. Here we are, public game 1, our constructor, default constructor. What are we going to do? We're going to set up a new graphics device manager and a new content manager. Well, that's pretty simple. So let's go ahead and jump back over here and add those real quick. So I'm just going to say new graphics device manager. And we're going to create a new content manager. And you got to be real careful right here with that graphics device manager, don't you, Logan? Because it looks like you've just created it, and yeah, you can start using things that require the graphics device manager to be involved, right?
Right, because, I mean, the graphics device manager is, of course, going to have a graphics device inside of it, and that's generally what you want to gain access to do something. If you want to draw, or if you want to create a sprite patch, you'll need that graphics device. But while we have the manager has to be told to create the device. And that hasn't happened yet. We've just made the graphics device manager. We haven't messed with it yet.
So we haven't finished setting it up properly, correct? So if we turn around and try to use things dealing with it, we can have all sorts of heartache. So all of these pieces right here take place when we instantiate the Game 1 class. Woo, that's simple. This part, now done. That brings us down to run, which is the next thing that happens. We call upon run. Now it's going to be game.run because we don't have any type of overridden run. I don't even know if it can be overridden. I would doubt it. But we don't have, well, let me just see.
Right. We're calling it for our instance.
That's right, but we've inherited it. Because down here inside of our game 1, we don't have a run down here.
Right, we haven't overridden it, like you were saying.
I was just curious, can it be?
We're calling upon run, which is obviously public because we're getting access to it outside of the class.
Exactly.
But we're obviously not overriding it.
Yeah, you can't override it.
It's merely public. So it's not meant to be changed when you make a derivative of game.
That's right.
It is available, though, and very necessary if you want whatever game you create to begin running, if you want to kick it off and get the ball rolling.
You got it. So we've now called upon run. So what does run do? Ooh, look at the very first line. This.graphicsDeviceManager equals. I'll be darned. We're now setting up the graphics device manager. Woo! So now we can use it. So check this out. If we were to turn around, come back over here, in our constructor, right here, if you were to set up the graphics device manager, and then set up the content manager, and then turn around and try doing something like sprite batch maybe, or anything else that's going to utilize the graphics device manager, run into problems, wouldn't we?
Right, because if you jump back to Reflector for a minute, what you're often looking for is the graphics device.
That's right.
And what happens on the next two lines? You have the create device.
Right here.
That's what needs to happen before you create a sprite batch. That's why you couldn't create it in the constructor, because if you're in the constructor, has been executed yet? No, it hasn't. So therefore, we don't have the create device.
Yep.
And that's why we can't create a sprite batch until after run is called.
Precisely. So the constructor just gets things set up, but we're not done. Run is now getting everything into motion. So far, so good. So let's go ahead and jump back over to the whiteboard. And inside game.run. So very first thing, let's just say, I'm just going to say, sets up graphics device manager. So now we have our graphics device as well. Yes. So what's going to happen next? Check this out. Next, we're going to, again, just simplifying everything, we're going to call on the initialize.
This is, of course, being the actual initialize, which is overridden in Game 1.
That's right.
So you can start to mark off things on your list in the left. There's our first call to something that we've seen. I mean, other than the constructor, obviously.
Yeah.
But now we're getting into things like initialize, methods that we're using.
So here we go. Our first call to one of our methods. Let's take a peek at it. Jump back over here to Reflector. So here we are. We just called upon games run. Come in here and we get everything set up with the graphics device manager. The very next thing, call on initialize. Fantastic. So when we get into initialize, what's going to take place? It's going to execute our initialize code. Well, I can show you this. We come over here. We've just jumped into initialize. So our code can then take place. At this point, we can make that sprite batch all day long.
I was about to say, if you remember back to past videos where we have made sprite batches, this is generally where we create them.
So we got a graphics device now.
And now if you think about it, going back to Reflector, do we have a graphics device at this point? Well, yes we do.
The answer is yes we do, because it was just created. So everything is in great shape now.
So that's exactly why we've been creating sprite batches from inside of initialize, is we know that the graphics device has been created, and looking at the code in Reflector, you can see that, yes, that's what has happened just before initialize, and that's why we wait until initialize to create a sprite batch.
You got it. So let's go ahead and jump down here. So, and I hate to do this, but I'm going to have to give myself some more writing room, so well, probably going to have to pull it down a lot. All right, so we call initialize, and inside of initialize, so let's just indent it, is our code. And then what happens? It calls on base.initialize. I'm going to show you that. So base.initialize gets called. Let's go back over here into Visual Studio. So look at this. We do our code. Then we call upon base's initialize. Well, let's take a look at base's initialize. Who's the base? The base is game, because that's who we've inherited from. So here we are. Once again, we're still in game. Let's come down a little bit. Now we run this initialize. So here, what we're going to do, now we're not going to talk about game components right now, but you'll notice we walk through all of our game components and initialize our game components. Hook device events, so just a little bit more to go, a little bit more to do. And then, of course, we check to make sure if our graphics device service is not equal to null and the graphics device itself is not equal to null. Then, and of course, all that's set up, so everything's good. We call load graphics content. So, let's jump back over to our whiteboard. From inside the base's initialize, we do a few little things, as I just shown you. I'm not expecting you to remember that stuff. The big thing I want you to remember is this. We now call load graphics content.
So there's another common method call that we've been using. So we can draw that back over into the list of methods we've been looking for.
So there's load graphics content with every ounce of its magic gone. And one of the most incredibly squiggly lines ever. There we go. So we now call upon load graphics content. Very good. So go ahead.
One other thing to point out with load graphics content is if you jump over to the Visual Studio project that we've got open and you look at load graphics content, you see there's a parameter for whether or not to load all content. This has been another magic value that is just handed to us. Generally, we've been loading everything at application load, so our code has been put inside of that block for if load all content. If you jump back over to Reflector and look at the call that is being made to load graphics content, we're sending in true. So we're basically telling it to load all content. So this is actually why load all content is true at the start of the game. Since this is the first call to initialize, this is where we're calling load all graphics content with that parameter set to true. So that's why that happens to be true at application load.
And if load all content, then here you go. Okay? Very nice. So, all right. So now that we have that done, so this is game run. So we've got all this good stuff set up. So what happens next? Well, now we're back up in run because we've done initialize. Bink. We've done our code inside initialize. We called bases initialize, which then called on load graphics content. And you'll notice in load graphics content, so here's load graphics content, we don't have any sort of base.load graphics content. So that's the end of the method call. So now we're going to start working our way back out. We're going to start unwinding the stack, if you will. So we back up and back into initialize that called it, which is back over here. So this is where we called it. There's nothing else to do, so we're now done with this method. So then we jump back out of this method back into the game's run, and here's where we called initialize to begin with. Now we set up, in run. So now we're going into run. We're about to kick it all off. The next point, what we're going to do is we're going to call on a method called begin run. This is very interesting. Once again, if we would not have taken a look at under the hood like this, you wouldn't have even known about begin run. I'm going to come back over here and add it real quick. Call begin run. Begin run's a very handy method that you can override in your game class to add code that needs to execute after all of your components have been initialized, but before the first call to the game's update. So you'll notice at this point we have not yet called update. So hang on, let me make sure this still works. There we go. So here we are, update. No arrows pointing to it. We've not yet called it. So now we make a call to begin run, and inside begin run, we can put our own code there for whatever it may be, but you have that ability. So even though right here you don't see it anywhere inside your game 1 class that you're currently working with, you can simply add it and override it. That means that it must be inherited from the game class, and it must be virtual. Let's take a look. So we'll come back over here. Again, we're still inside the game class. There's begin run, virtual. So you can simply override it. Notice it's empty, but you can add in your own code so that you can have something take place. Well, there you go. Called after all components are initialized, but before the first update in the game loop. And we've seen that now. So very cool. So let's go ahead and come back down here to run. So now we can see everything that's getting ready. It's getting up to that moment. We have a window sitting in memory. We've now got a graphics device manager and a graphics device. We've got a content manager. We've executed our initialize method. We've executed our load graphics content. We're almost there. We've now executed the begin run. Now what takes place? Game time, elapsed time, time span 0. So we set up some game time stuff. So we're doing a little bit of setup with our timing. So let's go ahead and jump back over here real quick. So I'm just going to call it setup game time. That would be game time. So more or less, just kind of think of it as zeroing it out. So we're getting everything set up. Why? Because what's the very next thing we're going to do? We make our very first call to update. So the very first time your update method, your code, gets called upon is not even in a loop. because we don't have a game loop yet, but we're going to execute your code one time. So we call update first time. And in fact, we're even going to store some information letting us know that we've done the first update. So we'll come back over here, and I'm just going to add all this to the same line, running out of speed. Well, I can go down a little bit lower, I guess. So set up game time, call, I'll just say first, call to update. And of course, we're going to pass it game time. All right, very good. All right, so once we get that done, what are we going to do next? Check it out. Jump back over here into reflector. So done. So as long as host is not equal to null, and we know we've got a host. I've already shown you where we've created a host. We're going to call upon host's run method. Okay, let's come back over here real quick. Here's our host. Let me grab an arrow. There's our host, pointing to a game host, which in the end is going to be a Windows game host. We'll see that shortly. But at this point, we're going to call on host's run. Oh, I don't know what I was writing there. So call host's run. Check this out. So that's it. Call host run. The end. That's the end of run. We're done. If we jump back over here, scroll back up, we've run the constructor for game, we've run the constructor for game 1, and now we've run the run method for the instance of game 1 and set a whole bunch of stuff up. So now it all gets passed over to the host's run. So for this, what I'm going to do is go ahead and create a new whiteboard.
Actually, before you do that, there's one tiny nitpick in the spelling at the bottom of that.
Oh, did I spell something wrong?
Spell that hosts with an S.
I did. No,
if you do an apostrophe S, that would make sense.
That's because the way I was... No,
but
thank you very much. It's host.run.
Yeah, the host field, we're calling upon its run method.
Yeah, and of course, as I'm talking out loud, I'm saying we're calling on the host's run method.
Yeah, the method that belongs to the host.
But as I was pointing out right here, it is indeed the host that we're calling upon. All right, so back over here to a new page. Thank you, sir. Let's jump in, add, and hide. Because we've got a few more things to put in. Because at this point, even though we've got a window created in memory, we've got game time, we've got a game clock, we've got a content manager, we've got a graphics device manager, we've got a graphics device, we've got all of these things. We've even run the update code once. We've run initialize, we run the load graphics content, all this stuff. But we have yet to show the window and fire off a game loop and see how we call update and draw as we do. So, what happens next? The next thing is we call upon that host run. So let's go ahead and jump into host run. So let's make sure I got plenty of room. So up here into host.run. So what takes place inside of host run? First, we're going to, actually, let's go ahead and just jump down here. So, where do we see this at? Well, actually, we can just trace it through. So, host.run. So, come over to host.run and check it out. There's run. It's an abstract method, meaning we're going to force whoever inherits this class to implement run. Who inherits from game host? Well, remember what I said? It's actually a Windows game host that we're dealing with.
But you can verify if you look all the way back in game, a Windows game host is what actually gets created.
Exactly. So here we are. So host is holding of a type of game host. But what actually gets created, as Logan was saying, is a Windows game host. So here's what we got created. That means since we inherit from game host, and game host contains an abstract method called run, Windows game host must implement that method. Let's verify that they've done it. Open it up. Run. Run's been implemented. Sweet. So here we are with an override to run, and we've got just a few things that are going to happen. I'm going to focus on two things. Oh man, look at that. Application.run. Now we're starting to see something that we saw a few minutes ago all the way back over here in this Windows application when we said application.run and we passed a window in. No, we're making some good ground now. So let's go ahead and jump back real quick here. Let's focus on these two very important things. These two lines here. This first line that I just highlighted. Application.idle. This is an event. An event belonging to the actual application itself. When we're finished processing a message and we are just about to go into an idle state. We are going to subscribe to it with the application idle method, meaning that when this idle event is raised, it is going to fire off application idle. Here is application idle. It exists inside this Windows Game Host class. So when this event gets fired off, the application, so the whole program, the program's idle event gets triggered, we're going to call on application idle. Okay, and inside application idle, what do? We do a few little bitty things, but we call the bases on idle. Keep that in mind. We're going to come back to that in a second. So let's jump back in here to run. So first thing is we register the event handler application idle to idle. So let's go ahead and jot that down. So subscribe. Let's see, how do I want to write this? Application idle event handler method. Jot it all out. Event handler to application dot idle event. Sound good, Logan?
Yeah, it's hooking up a method so that we can, 1, be notified of whenever the application becomes idle, and 2, have our own custom code execute whenever that happens.
Precisely. Then after we do that, the final thing that we do is we call application dot run. And we pass it game window, and I'll show you this in a second, dot form. And game window dot form, basically the object game window exists and it has a property called form. And what form does is it returns a property, or a field called main form. And main form references a true Windows form. So we're passing a true Windows form to application.run. So what does that do? It does two things. Number 1, it begins a standard application message loop and 2, it makes a specified form visible. Now, I have not yet walked all the way through the creation of that form. We'll do that.
But what's cool is we have indeed actually found a form. That GameWindow.form is a form field held within GameWindow.
That's right.
So we have an actual form, and we're feeding that to application.run. So we have found the same line that we were looking at back in the Windows test application, where we had application.run taking in a form and making that form visible. We have finally found that line.
You got it. So, yeah, we've seen it. So now you see why I had Logan create a Windows application at the very beginning, because I wanted him to show you that application.run. And here we are with our own application.run. All right, whew. Now, that's it, because now we have two very important things going on right here. We now have our standard application message loop running. So now we can trigger that idle, application idle event, which will call application idle. It'll make application idle automatically run. What does application idle do? So let's start looking at that, because this is where it all happens now. Because at this point, actually, you know what, Logan, thinking about it, let's jump back over here real quick. Did I? Ooh, I did forget. We both didn't catch it. Let me put focus down here real quick. We've not yet drawn or called upon draw. But you know what we forgot?
We haven't drawn our first line to the initial
We have,
update.
that's right. We did call update for the first time.
We haven't established a loop yet, but that call was indeed a call to the actual update method.
That's right.
That our code resides in.
You got it. So all we got left is the draw. There, I feel better. Just realized that was missing.
But yes, like you were saying, that means we've called everything except draw up to this point.
So what takes place? All right. So here we are, and we've got application .idle. And this is an event. This event is going to trigger. Now, keep in mind, what are we in? We are in a Windows game host. Let me show you. So here we are. Here's the run. Here's where we hooked up the event. Let's trace it back. Where are we at? We are in a Windows game host, okay? So we're now going to call on the Windows game host. The only reason I'm writing this out is because we're going to jump around just a little bit. I need you to understand what object we're in. So Windows game host, application idle. Okay, so let me see if I can do this. Application.idle triggers our Windows game host application idle. What does application idle do?
And if you remember, of course, application idle is that method we touched on briefly inside of Reflector.
You got it.
It also resides within Windows Game Host,
yep.
And it is the application idle method.
So it's our event handler. Let's jump in here. What does this guy do? All right. Ooh. We have a while loop. While not peak message, sending out a message and all. So while we're not peaking a message, let's just keep this real simple. Then if we exit request, if that's been found, close the game. Let's not focus on that because we're not closing the game. We're focused on running. So if we're not in the middle of processing any sort of message whatsoever, or about to be processing a message, we're going to call on the bases on idle. Well, what's base? Well, who do we inherit from? Windows game host inherits from game host. So we're going to call on the game hosts on idle. So you can look at this as game host on idle. Let's jot that down. So here we are, game host dot on idle. So you can say that application idle calls gamehost.idle. All right, so far so good. Let's jump back over here and let's come up here to, now of course I could just click it over here, but I want you to see where I'm going. Gamehost, open. Gamehost has on idle. So we just called on base on idle, so that's this guy. What are we doing in here? This dot idle, if it's not equal to null, well, we're idling. So what are we going to do? This idle, ooh, that has the signature of an event handler. So we're calling on idle. What are we doing actually? We're raising an event. Okay, and I said event handler. Let's go ahead and jump back over here. So on idle actually raises an event. And let me show you that. If we come back over here, here we are on idle. We call upon idle. So if we come up here to game host idle event. Okay? So let's go ahead and jump back over. So game host dot event, game host dot on idle, or idle, excuse me. All right, so I'm going to raise an event. Now the question is, does this event have any methods subscribed to it that will get triggered?
That's what's going on with that check for if it's null or not.
That's right.
If you look back inside of on idle for the game host.
So hang on, coming down to idle.
Up just a little.
Wait, on idle, there we go.
Because as you were saying a second ago, we've called this. Now we're looking at, do we have an idle event subscribed? And if so, then call it.
And we do have one subscribed. We have the host idle. And where did that happen? We've actually seen it. If we come all the way back up here to game, and inside game, when we did the constructor called ensure host to make sure we had a host. So there's our host. Check this out. Down here, there's the host idle. That's what we're looking at, because what is the host? The host is a Windows game host, which inherits from a game host. So now, back with the idle, let me make sure I can keep my eyes clear on what's what. So there we are, game host, idle. So you can see what we're doing is we're subscribing to the event with host idle. So that means when we raise the idle event, it's going to trigger host idle, which is back up here in game, and host idle right there. Very nice. So let's go ahead and add that in. Let me go and give myself a little bit more room. All right, so game host idle calls game host idle. Let me put a dot in there. And it's not that it calls it. Let me rephrase that. It triggers it. Because we had an event raised. All right. Well, what does host idle do? Let's jump back over here. So we're now on host idle. Host idle calls on tick, which is right here, which has a lot of code. So let's jump back down here. So now this is called game.tick. So calls. So game host idle calls game tick. So what does game tick do? Well, there's a bunch of stuff, and we're not going over all of this. We're going to come down here and make sure, blah, 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 stuff. The most important thing that I want to get down to, because this gets into some logic dealing with timing, right here. It calls update, passing the game time. There's another call to update depending on where in the if we are. So update gets called. So let me do this. So I'm going to start back over here since I'm running out of space. So we're going to have game.tick. So that's what we're in. And what game.tick is going to do is call update. And we all know it passes the game time in, just to save some writing time. And then what does it call? So it calls our updates, and then finally it calls draw frame. Let's add that into the whiteboard. And once again, with draw frame, what does draw frame do? Draw frame takes our game time and basically sets our game time up utilizing our clock and some other elements. So basically gets all that set up and then finally calls draw. So there's draw. So draw frame calls draw. So now we have seen back over here that Yep, so let me go ahead and get focus real quick because I do want to do a little bit of drawing on here. That tick is responsible for calling update, and it calls draw frame, and what draw frame does is turns around and calls draw. Whew. All right. Interesting thing to note here. If we jump back over real quick, this entire thing that I've got drawn out right here, dealing with our application.idle, this is an event at the application level. When we go idle, the event is triggered. While we are idle, we're sitting there inside that loop. As soon as we have a message to deal with, the application is going to deal with the message. But when we're not having to process any Windows messages, then what's going to happen is we're simply going to have the idle event get called. That idle event is going to trigger our application idle, which is in turn going to turn around and call on the on idle, which is going to raise the idle event, which is going to trigger the game host idle method, which is going to call on tick, which does some timing stuff, calls update, calls draw frame, which in turn does draw. This is constantly taking place. Each one of those noises you just heard is a sound. As you know, right now we keep things tightly controlled in such a way that update runs 60 times a second and draw runs 60 times a second. Okay? So even just dragging a mouse across, Logan, will dragging a mouse across your application have an event that's going to tie it up in such a way that our update and draw can't function because we're outside of the loop now because we're processing a Windows message?
Well, it's an event that will get handled so quickly, you generally won't even notice it. Because,
exactly.
I mean, if you consider how fast a computer can process things, doing something simple like calculating a few numbers isn't going to be noticeable inside of a 60th of a second. Instead, it's going to take something that's probably going to be closer to a nanosecond.
You got it.
While, yes, at some level within the application that is causing things to fire off, it's one, things we generally aren't too worried about in a game, and two, things that will happen quickly otherwise. So really, we're going to spend most of our time after each idle occurs stuck inside of a loop that's just drawing the game. Sure, if something needs to be processed, if an event needs to be handled, we'll jump out of that momentarily to handle it at the application level, and then come back and basically we'll handle that, which will happen quickly.
As soon as we're done handling,
what happens afterwards? We become idle.
Right, we fire that idle event, and this chain reaction takes place, resulting in us getting up here into tick, which is then going to take care of update and draw. And it's just going to keep firing over and over and over. So there you go, the entire trace right here on this page. And all this gets kicked off with a call to host's run method. Okay? All right. Very good. So, ladies and gentlemen, at this point, please feel free to pause your video and go get some coffee or popcorn and Coke. Or take a bathroom break, because I'm going to do some more talking. What I'd like to do now is just show you a very simple snapshot of the heap. That right there could make some people go, that sounds scary. But a very simple snapshot of the heap with the game in there and the objects that create our window. I think that'd be cool. And maybe some of the other things as well. Let's just have some fun with it. I mean, at this point, the bottom line is, let me throw this out as extra. If anybody wants to quit the video, they can quit the video. Otherwise, it's really good knowledge. So let's go ahead and jump in here and create another window. So, Logan, so far, how's it going?
I think it's going all right. I mean, there's a lot of things we've had to trace through, but each of those things have been relatively simple. It's really just one thing calls another thing in a chain. Yeah,
so I'm happy with it so far. All right, so now what we're going to do is take a look at the heap. We've drawn the heap before. I'm going to create my game 1, but remember, my game 1 inherits from game. So I'm going to draw a game, and we know inside of game, go ahead and make some room here. We've got a clock, and that's going to reference our game clock. We've got game time. So basically I'm drawing you the big picture now. And we've got a host. And we've got a lot of other stuff too, keeping it as simple as possible. So I'll just draw this on down, something like that. Finish off all these wonderful lines. So once again, just fields. These guys are going to reference objects. Now, we also, in here, here's game 1. So remember how I like to draw these objects that inherit from other objects. So we view the whole thing as a single package. This is a game 1, okay? But I'm showing you the classes that make it up, because they all do get loaded onto the heap. So inside here we have things like content for content manager, and our graphics, and let's say just throw in our two big ones: update and almost had the length right, and draw. Okay, so once again, so we're looking at just a really very generalized snapshot of the game 1 object. Okay, now we know that we've got sitting over here some objects. So this one right here is going to be our game clock. And we've got game time. And a content manager. And the big one. And in here, a graphics device manager. Okay, our clock is going to be a reference to a new game clock. Our game time is going to be a reference to a new game time. Our host we'll get to in a minute. Our content is going to, down in game 1, is going to reference a content manager. Graphics is going to reference the graphics device manager, and inside the graphics device manager has a device along with other things, but the important one. And over here we have the actual graphics device,
which we know from creating sprite batches. And this diagram now explains why when we create a sprite batch we have to access through graphics.graphics device, because we have graphics, but then we have to look into graphics and find that device field in order to gain access to the actual graphics device.
And here it is. Think right there. Okay? So, we have all that. Very good. And all that, we can actually start to trace some of this out now so that all this starts to make sense. So, once again, come up here to game, into the constructor. There's game time, so we got a new game time object. Very good. There's clock, new game clock, and we've already traced through and we've seen the graphics device manager, we've seen the content manager set up and all that, which was located back over here, right here. So there's graphics, where I got the word from. There's content, where I got that word from. And there's where these guys got set up. Okay, and you already saw where the graphics device got set up as we dug deeper. Now, what I'm interested in this part of the conversation is for us to have a conversation, like we're just chatting, yeah. Okay, this part of the lesson. What we're going to do is take a look at where the window comes from. This is what I'm most interested in. We've, at this point, only focused on game host, and we've mentioned the Windows game host. But how does that go further all the way down to a form, so an actual system form? So let's take a peek. All right, so host is going to create, or excuse me, is going to reference, let's see if I can draw that just a little bit better. It is going to reference a Windows game host. So I'm going to come down here, give myself a little bit of room, draw out some more objects. So here we are with a game host, as we've already seen, and we've had to do some digging around inside of it as well. And then here is a Windows game host that inherits from game host.
And we have seen both of those.
Yes.
At least roughly, because we've seen the game host, which is the type of the field held back in game. We've seen Windows game host, which is what actually gets put into that field when we start running.
And I'm just going to draw two things inside the Windows game host. I'm going to draw game, and I'm going to draw a game window. Because game window, this is where we start to get all of our references now. What am I talking about? Is it back over in this one? Actually, no, I think it's in this one. We got so many of these guys now that we are game window. Okay, so there we go. So that's like, where does this stuff come from? Now we're starting to get into where some of this stuff comes from. So let's go ahead and jump back over here real quick. So here we are. Host is referencing a new Windows game host. When we create the new Windows game host, we pass a reference of game to it, so of ourself. So that game, I'll do it on this side here. So game will point back to us. Okay? Let's take a peek at that. So now we're going to start following this through. So here we go into ensure host, because that's where this begins, because it's all about creating this new host. So host, which is of type, let's go back to what Logan said earlier. Host is a game host. But when we actually instantiate, what do we instantiate? So once again, let's come back down to ensure host. We instantiate a Windows game host, which is still of type game host. And we pass ourself to it. So let's go to Windows game host. Windows game host takes a game in, and that's what I just drew on the whiteboard. That is our reference back up to ourselves. Okay? So now let's take a peek at what happens inside the Windows game host. So come back down here. So Windows game host, I'm now on the constructor. Windows game host takes its field game and references that back to the game that we just sent in. So now we've made this association back and forth. Then, I'm very interested in this line right here. We create a new Windows game window. All right, what is a Windows game window? A Windows game window inherits from a game window. So let's go ahead and create that object now back over here. Or at least load that onto our magic little heap. So here we are. Same idea. We've got a game window. So you can now see at this point, as we leave away from the host, get further and further away, we're definitely all in the Windows world. So this is a Windows game window. So Windows Game Window has one field that I am interested in, and that is main form. Let's take a peek. So right now, this new game window references a new Windows game window. So let's see that. So back over here in the constructor for Windows game window. Wait a minute, did I go one too far? No, Windows game window. No, I have gone one too far. Hang on.
Are you looking for a main form?
So game host. No, I'm right there at it. I jumped out one too far. So let's go back up here to the host because I just wanted to show game window.
I got you. Game window itself.
Yep, that's why I just wanted to show the association. So there's that game window to a new Windows game window.
Just to reiterate that.
Yep. Game window to a new Windows game window. Now main form. So what does main form do? Let's go and jump back over here. I managed to almost get myself lost. So back over to the Windows game window, into the constructor, the main form holds a reference to a new Windows game form. What is a Windows game form? A Windows game form inherits from, there it is, form.
So just like Form 1 did back in the Windows test application.
Exactly. So we've inherited from the exact same thing that your Windows test application inherited from for getting its form. So let's go and draw that into the picture here on the heap. So creating two more classes to represent my object. Form, which is outside of the XNA world, and Windows game form. So, main form is referencing a Windows game form, which is of type form. It is a window. So there you go, except we've just got a few extra things going on. Basically, we're getting a series of events all set up so that we can start grabbing some of that stuff back this direction. So let's go ahead and jump back in here one more time. So here we go. A Windows, this time I won't make the mistake. We'll jump back to a Windows, or jump down to, so Windows game window, constructor, main form, Windows game form. So there's where it gets created. We're holding the reference to it. Now, let's see. Is there anything else inside here I want to show you? Yes. Inside Windows game window, there is that property called form, where we can get a form. We can return back the form. So what does that actually return back? If we come in here, check it out. All it does is it returns main form back. So this is our form property. So let's jump down here. And all form's going to do is just take this and return it back. So now you can see where we were going, application.run, game window dot form, and it returned back our main form, which was referencing a form. So there's all of that. Does that make sense, Logan?
Right. Well, I mean, there's where we got an actual Windows form and handed that off to application.run. So now everything is looking almost exactly like the Windows application, except less simple. There's more things in the way that give us more control over different aspects so that XNA is able to function properly. But in the end, one can still trace through all of the classes available and find the actual form that is handed to the actual application when running begins.
You got it. So at this point, do you think we've covered it well enough?
Oh, we've traced it all the way down to the root of form. We've traced it all the way down to the root of application. This has given us our physical window that we can see. It has given us access to the application where we subscribe to the event.
Let's back up to that first page where you're talking about.
So we start to fill some of these things in, like the window. we've seen that. We've traced it down to a Windows form and basically found its counterpart for the test application that we had made. So we found that. The game loop. We found application.run, and we know that it has the onIdle event. We've hooked up a handler to that, and then through a series of things drawn on one of the other pages, we found that that series of things from idle ends up tying into update and draw. So we've filled those things in. And we've already filled in things like initialize and load graphics content just from creating the game itself, back up in the base game.
Whew. Man. Oh, yeah. The biggest thing, in case you have any more questions or concerns about the timing, it's all in here. Whoops. It's all can be found inside of here. It's all through the connection of the application idle method to the idle event. Go into idle, call this. This guy turns around, calls on idle. On idle raises the idle event. The idle event causes the host idle to get called. Host idle calls tick. Tick calls update and draw frame. And draw frame calls draw. Again, this is and this just continues to happen over and over and over and over and over while we don't have any messages to process. And you've seen the while loop now. This again is just a very simple overview of the entire thing. But I think we've covered all of the areas pretty well. And once again, here's kind of a map of just some of the basic stuff that's happening in memory.
Right, this is a good overview of all the different things that we were jumping between when we were in Reflector.
Yeah.
This shows a lot of the different classes at the same time, from the game to the game host to the game window to the game window and to the form.
You got it. So, yeah, with that, just jumping back over here to this real quick, we started out with a simple box that said XNA game, talked about some of the components that went inside it, and then just slowly started breaking it down. And I think we've done a pretty good job of breaking it way down to the point of where everybody should be able to follow everything. Just don't forget, that ensure host is such an important method because it's what establishes the environment. It gets that host up and running. And that takes care of getting the application running, getting the loop going. So ensure host located all the way back, way up here in game.
That's where we really start to break out from just inside of a simple game.
Yeah.
We start to tie into some support classes, which eventually tie into roots within the Windows platform itself.
Exactly. Section's just so important right here. Well, it all is, but you know what I'm saying. All right, so there you go. A quick look at under the hood of a basic XNA game. And with that, that wraps up this video. Thanks a lot, guys.